Hi students, today we will discuss the very basic concepts regarding electrostatics, the very first chapter that you are going to study in class 12. The concept of electrostatics starts from the concept of charge. What is charge? Remember that charge is equivalent to mass. That means whatever mass plays the role in gravitation, the same role charge plays in electrostatics. So basically what happens is that between two point masses, there is attraction given by Newton's law of gravitation. Newton's law of gravitation is called first inverse square law. And the force of attraction or the force of repulsion between the charges is called Coulomb's law. And Coulomb's law is also known as second inverse square law. Now, there are a lot of similarities between the charges, like mass is equivalent to charge and charge is equivalent to mass. That's why some scientists, physicists, they call that mass is Newtonian charge and charge is Coulombian mass. It's a very interesting concept. Now, what are the dissimilarities between mass and charge? Now, see, between the point masses, there is always what? Attraction, but between point charges, there may be attraction and there may be repulsion. So, these are the two things, and another concept is that quantization of charge. Like charge is always quantized. Now, what is the meaning of charge is always quantized, mass is not. So, this means that mass can have any value, but charge cannot have any random value. Charge will always have an integral multiple of electronic charge. Okay. Now, what is an electronic charge? The charge of an electron, 1e, is equal to 1.6 into 10 to the power minus 19 Coulomb. So, this is the charge of an electron. It's a positive charge because I have taken plus e. So, you can also say that it's a charge of positron. Now, for electron, there will be a negative sign. Okay. So, what is quantization of charge? Charge, which is Q, must be an integral multiple of electronic charge, and it can be plus minus. If it is plus charge, then it is for positron. If it is minus, it is for electron. So, like fractional charge, for example, E by 2, E by 3, etc. are not possible. But these kind of charges are possible in quantum electrodynamics, where we study of a particular kind of a special kind of a particle known as quarks. So, for quarks, these charges are possible, which are not included in our syllabus. Now, let us discuss Coulomb's law. What the law is saying? The law is saying that suppose there are two, very careful here, two point charges. So, these Q1 and Q2 are not any charges. They have to be what? They are point charges. And the separation between these two charges is R. Okay? And the medium also plays a major role here. In case of gravitation, the medium has no role between the attraction. The medium plays a major role in case of repulsion or attraction between the charges. The law in its scalar form says that F is equal to 1 by 4 pi epsilon m Q1 Q2 divided by R square. This is the equation, the scalar equation of Coulomb's law. Here Q1, Q2 is pretty easily interpretable. They are the values of the charges, which are the integral multiple of electronic charge for these 2 point charges. R is the separation between the charges. And what is this epsilon? This is the permittivity of the medium. What is the meaning of permittivity? Permittivity means it's kind of difficult to make you understand, but I'll try. Permittivity is a mathematical measure of restriction provided by the medium to the interaction of the charges. Okay. So, for example, remember that suppose, imagine like this, suppose there are two friends and there are a lot of restriction from both of their house that you can't talk and they can't talk between each other. So, what happens if the communication goes off? If they don't communicate, do you think the friendship, the bonding remains very strong? The answer is obviously no, right? So, similarly, the permittivity, this quantity epsilon m, is the mathematical measure of restriction provided by the medium to the interaction of the charges. I hope I made it clear. Now, which medium do you think offers the highest possible restriction to the interaction of the charges? And that medium is a conductor. So in case of conductor, imagine like a current carrying wire, and you switch on the light. What happens? The bulb or your TV or anything, any electrical appliances just switch on. Why? Because in the conductors, electrons are moving. Now, electrons are like charges and they must repel. But in case of conductor, their repulsion is zero. And how their repulsion is zero? There is only one solution for their repulsion being zero, is that the permittivity, epsilon m, of the conducting material is infinitely high. And if it is infinitely high, it is the denominator. You can easily understand if the denominator becomes very high, even though these two values are reasonable, are finite, this force will become zero. So force of attraction and force of repulsion in case of conductors is zero. So this is the foundation of the first chapter, electrostatics. We will discuss more in the next video. Tata, see you in the next video.